write it like this. A squared b, I'm just going to do it simply like this, ab, minus, let's get rid of these numbers here, so this is going to be once 3 times. So I'm going to get minus 3, the 3 staying? Yeah, 3 stays. So I'm going to keep that numerator. So I get minus 3ab squared all over ab. I'm just copying down. Basically, the numbers cancel, so all I did is put the variables back up. If I'm assuming I copied it down right. And then these numbers, 4 goes into 12 3 times, and then I got the ab squared over ab. So I'm just taking out the numbers, most of them anyway, and now I'm going to deal with the variables. And that's where I apply these rules. So which rule applies here? Boop, right? Upstairs, downstairs, or this, so I can say a squared minus 1. And then this is b1 minus 1. Taking this in steps, this would be 3a1 minus 1 and b2 minus 1. So I'm using that rule of upstairs, downstairs. Everybody follow me? Everybody follow here? Everybody follow me? Okay? So now, what's a2 minus 1? So this should be a, right? Or to the 1. b to the 0 minus 3 a to the 0, and then b to the 1 power. So b to the 0 power is 1, and a to the 0 power is 1. So what's left is a minus 3b. Sono finito, I am finished. There you go.
On the homework, we don't go through all that. That just cancels everything out from the beginning.
Yeah, that's what I did.
I'm taking it slow. I'm taking it step by step. You can if you're on these exponent rules, yes. But for purposes of others,
But I mean, on the homework, will we get counted off if we don't?
no, unless you show me something. I want to see something.
Okay.
I want to see something. You don't have to do what I do here, all of it. But I just don't want to see this. If I see this after this, then you're going to lose some points. Okay?
Okay.
All right? Maybe not. Full point. That's the shrewd property. That's about as tough as they get. They get a little harder than that, but not a big deal. I got to move forward. I got to move to the next thing. Next thing is something called, we evaluate next, right? Let's see here, distributed properties are okay. So the next thing I want to do is do something called factoring, and then evaluate. Now, we're not going to get into the heavy-duty factoring that you all experienced in high school. We're just going to get to the light end of it. We're going to just learn about one factoring method, and it's called the GCF method. We've seen GCFs before, yes?
Yeah.
We're going to actually see them again. What's the GCF stand for again, by the way? Greatest common factor. So, but we're going to do it with something called monomials or expressions. For example, if I want to factor, let's factor a couple examples here. Let's say I want to factor 15a squared b. That's a good tune, but keep it down. That's a great tune. Oh, Charlie Daniels Band. Okay, so when I want to factor this is I want to pull out my factors. In other words, I can do a factor tree. I can say 5 times 3, and then break down the a's. So this is sort of this more simplistic one-term expression. Notice this is one term, and if I factor one term, I'm just going to break it down into just its individual pieces. Okay? All right. But more importantly, the factoring is going to come with 2 terms. For example, if I have, let's do another example. Again, factor this one as well. So if I have, let's do this one, x squared y plus x plus x, xy squared. Just another example, and I want you to factor this. So factor this. Now when you factor something like that, it's 2 terms, right? You see 2 terms in here? See this plus sign? Means there's 1 term, 2 terms expression. It's a 2-term expression. So if I want to factor the two-term expression, I got to pull out what they both have in common. X's and Y's, but not all of them. So if I have two in here and one there, the only one in common is just the 1. So I pull out the 1x. Here I have 2 and 1. The one they have in common is the y. So I just pull out an x and a y, and what's left is x plus y. So if I distribute back in, I should get the same answer. So if I distribute back in, I get x squared y. I get x squared and a y. And in here I get a y squared and an x. So by distribution, which is the opposite of factoring, by the way, the opposite of distributive property is something called factoring. Okay? So this is properly factored, or fully factored, I should say. So this is fully factored. Let's try another one. Everybody following me here? Should. Let's do a tougher one. 12x squared. 12x squared. Where are you? Minus 36xy cubed. Let's factor this bad boy. Completely. Factor completely. I may have to define completely, but let's just see how this goes. Some people factor, but not completely. So here's my another example of factoring. Factor completely. What I want to do is I want to find out what they both have in common. So if I think about 12 and 36, they're factors of each other, right? In other words, 12 times something gives me 36. So they both have a factor. Now you can do it like this. 12 times 1 and 12 times 3. This might be sort of a step-by-step way of doing it. And then, so they both have a 12 in it, right? We also have an x in both of them, but not, so if I have x, that's x squared here, and here I have x, y, 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 now we can see what's common, right? What's common are the 12s and 1x. This is how you break it down piece by piece, just to figure out if you got to everything. This is completely, this is sort of getting into it completely. Yes? No, because I only have one x over here. I have 2 x's here. I have 3 y's there. This is an xy cubed, so that means I have 3 y's. So now, let's pull out what's common. So I've got a 12x, and then I'm going to set up a parentheses. And what's left is 1x, or just x. Here's my minus sign. I'm going to keep that consistent. And then what's left here is 3y squared, 3y cubed rather. And so now I'm factored completely. Yes?
Did you use a 6?
Say what?
Was 6 be possible? Did you use a 6?
Well, if you did 6, you could, but it wouldn't be factored completely. So this is 6 times 2, and this is 6 times 2. Oops. If you just pulled out the 6,
I got 6.
you still got 2 left. You still got a 2, it's not factored completely.
I think 6 times.
6's work, but it's not factored completely, and that's usually where students lose that piece. You've got to factor it completely. And the 12 is the best shot. 6's could work, but not completely. Okay? Let's do 3 terms, and we'll be done with these guys. Let's try one of these on the page here. Let's do, we got fractions. Oh my gosh, look at those. All right, look on page 160. So page 160, and let's do that number 7, lucky number 7. And it's as follows: minus 4a squared b plus 8ab minus 6ab and squared. Make sure I wrote it down correctly. Yes, Kristen?
Shouldn't that 6 be 12?
It is. She wanted me to change it to 6, and I was just demonstrating that the 2 got left over. So yeah, this should be 12. 12x. That was my original. But I wanted to demonstrate the completely factor. which is a good question, okay? All right, let's get to that third one. That last one for this distributed property business. Why don't you take a shot at it first? Take a shot at it. I'm going to break it down the way I did it here. Try and break it down here. If you're not quite familiar with this factoring business, or it's haunted you all through high school, then I would try to break it down here first, like I did here. That's the way I would do it, even though with 3 terms. It's going to take a little bit more work, but you have to see it. You have to be able to draw a picture in your head. Okay, I'm going to ask now, if you've broken down this first term. Hassan, did you break down the first one? Well, tell me just break down that first term. Notice I did the 12x squared. I broke it down to 12 because I knew they both have 12s. But if you don't, you could break this down into 2s. They're all even. So we know there's a 2 in each one of them, right? So why not just break this down into, we'll say -2 and 2. Right? And then I've got A, and an A, and then B. So there's my first term. Okay, that's my first term. My second term, I've got actually, how many 2's do I have in there?
4.
I've got 4, not 4, but 3 actually. 2 times 2 times 2. So I can say 2 times 2 times 2, and then I got A and I got B. And then there's a plus there. We'll put that plus there right like that. So 2 times 2 times 2 is 8. Right? Everybody following me so far? This last one, let's do that in a different color too. How would you break down this